So we really quickly went through this one. So remember when we set up our conversions, we need to follow a process. Based on submissions that I've seen or talked with people that I've had in the learning community, or not learning community, in the learning center, I'm seeing a lot of people kind of falling back on their old methods to go through and solve things. There isn't necessarily anything wrong with that as long as you get to the answer. What I have found is that those other methods are not consistent and you don't get to the answer the amount of times that you would appreciate. 70% of the time isn't all that bad, but that's still, if we look at 90, 80, 70 cutoffs, barely a C. Okay? So what we want is a method that works all of the time. We have to really push to find a process that always works. Okay? As we go through and even set these up, one of the things that we have to watch out for is there are tricks and pitfalls that could always come in and kind of tank any kind of practice you go through and run with these. Okay? So if we take a look at this problem, what are we aiming to solve for? Inches cubed. What are we starting with?
Centimeters cubed.
Centimeters cubed. How many centimeters cubed?
490.
Okay. Centimeters cubed is not the same thing as inches cubed, so what might we do?
Cancel out the centimeters.
We want to cancel out the centimeters. We want those units to disappear. Okay. And this is where students go, oh, centimeters to inches. Oh, I know that conversion, either because I've memorized it or I look at the front of the exam and I find that it's there. Right? And we look at it and we find that the conversion is 2.54 is 1, right? Okay. Got a lot of people shaking their heads. Yeah, that's right. No, it's horribly wrong. Okay? Just because you know the numbers doesn't mean they've been placed properly. Look at your conversion again. It's 1 inch equals 2.54 centimeters. Where does the 2.54 go? It does not go on the bottom. It goes with,
Core unit.
there is no core unit here. We're changing metric to English. It goes with centimeters. Okay, and for those who are saying, well, that's on the bottom. It's on the bottom this time. Don't memorize that it's on the bottom, because then you will place 2.54 on the bottom regardless of what the unit tells you to do. Okay? So you need to be placing the numbers with the unit, not based off of a location. Okay? Would this solve the question?
No.
Okay? No, because that's centimeters cubed. So what do we do?
You had to do it again 4 times.
I'm actually going to skip your suggestion. Okay, we'll come back to it.
All right.
Okay. Usually what students will go through and do is say, oh, well, it just needs to be cubed, so I can cube it. Mathematically, it's a bit questionable.
Yeah.
Okay, just based off of the presence of where those things show up. Okay, I understand what you're attempting to go through and say by this, but when you go through and enter it into the calculator, what do you enter in?
You're entering just regular centimeters and inches.
How would you enter it into the calculator? Walk me through it. You turn on the calculator, right?
Right. I think that's the
And then the next step would be 4, 9, 8 divided by 2.54. Wrong answer. Because it has to be cubed. When you dropped that cubed, you were referencing the whole thing. Okay? And that's where you have to be careful. So there's a couple ways out of that. Make sure you're doing it mathematically correct in your calculator. If you've got a nice graphing calculator that shows it all out, you can probably pull that off. If you're using one of the smaller scientific calculators, you might need to actually solve these pieces independent. First do 2.54 cubed, which is 16 and change, I think. Yeah?
16.387.
Okay.
16.
Then you can take 498 and divide it by 16.38.
Oh, that makes sense.
Okay, that would work. Okay, as was suggested by one of your classmates, we could instead, and this gets a bit tedious, but this at least shows each of the steps. Centimeters cancels with that 3 to make the 3 a 2. Okay? I don't have my answer yet, so I have to do it again. What's my conversion between inches and centimeters? 1 inch is 2.54 centimeters. So the centimeter cancels with the 2 and makes it just a 1. Oh, I don't want that. So what do?
You gotta do it again.
I do it again. 2.54 centimeters. Now the centimeters cancels all the way out. And now I'd be left with inches cubed. By writing all of the work out, you minimize the chance for making a mistake. Okay? There's a reason I have the stupid, whatever that bug creature looking lobster guy is up there. Okay? Lots of people screw this up because they go through the first process. Oh, we just put a cube and it's done. No, you have to cube all the numbers. Okay? So watch out for that. Be careful with it. When you see those exponential units, you're going to have to track those conversions a little bit more carefully. Make sense?
That makes sense.
Okay. So our process, what do we want as an answer? What are we given to start with? And then start your conversion factors. Okay. Notice, I've done a bunch of conversions in one line. This simplifies the amount of work I can go through and do. It makes life a little bit easier for me to deal with. Okay. If we go through the old methods, you end up doing each of those as independent calculations. That can take more time, and it takes more writing. The more writing you make, the more likely you make a mistake, and you end up entering the wrong thing into the calculator. Okay? Because I don't think enough people are actually trusting that this method works and relying on it, particularly based off of submissions I've seen for short answer B, okay, with people just being like, I have no idea how to answer that question because we haven't talked about it. The short answer from the practice exam, we have absolutely covered everything you need to know to answer that question. So if you've looked at the practice exam and you're like, I have no idea how to do this, you do. Okay? But what happened is we incorporated Snorlaxian Skittle farts. Remember that slide?
Yeah.
And you were like, yeah, that was just a stupid slide. Why do we even look at that stuff? For that very reason, you have no idea what those terms mean, so you can't mathematically manipulate those in your head. You have to have a process to follow through with them. That's the whole point of that Snorlaxian Skittle fart slide. Okay? And because that one's so bizarre and silly, everybody just kind of ignores it. So let's look at a real example. Okay? How many seconds of molecules of caffeine are in 0.0350 grams of caffeine? Okay? You have all of the ability to be able to interpret this. There's a bunch of text there, and it's confusing to go through and process. But that question, 100% fair game for this exam. Right? It involves all of the content and the process behind it. You think you can solve it? Ooh, some people are saying no. There's some confidence. Okay? Nobody shouted out yes. Okay? That's a bit fascinating. You have the full-on ability to do it. It's just a question of how do you go about doing it? Well, step one, what do we want for an answer?
Seconds.
Do we want just Sagans? Sagans of molecules. Molecules of water?
Of caffeine.
Of caffeine. So if we were to go through and write this out, I'd have to put my equals. And I have Sagans of molecules of caffeine. And since I see at least one person in my periphery, I spelled that wrong? No, I spelled that right. Writing that out, this is where we might pause. If I asked you to write down hydrogen, what would you write? H. Okay, or even H2. I'd accept both those answers. Why did you not write out HYDROGEN? Hydrogen. Because you're lazy. We don't want to write out all those words. Do you really need to write out all of those words? Could you come up with an abbreviation to make sure you've incorporated all of that? Okay. I heard a couple suggestions. Okay. I heard SMC. Sagan's, molecules, caffeine. And we dropped the O's. A lot of people seem to want to include the O's, and just because it makes it sound silly, we can go through and do that. Okay? We're being asked to solve for SOMOC. Okay? Which means when we go back up to the question, this isn't how many Sagan's of molecules of caffeine, this is how many SOMOCs. Okay? Are in 0.350 grams of caffeine. We already made a simplification in the sentence. Does it actually spell out grams? No. Shows G. So 0.0350 what? GOX. Okay? For those who are going, God, that's really weird and awful. Why would you ever do that? Look at everything underneath it. You're going to say GOC is weird and uncomfortable, but grams of caffeine, writing out half a dozen different times, you're going to be okay with?
No.
Okay. The other part of this is now, what do we start with? Okay. What should I write on the left-hand side? Why are you writing GOC? What did you say? Because I gave it to you. Did I also give you that 1 Sagan of molecules of caffeine equals 4.00 times 10 to the 9th molecules of caffeine? Was that also given? Yeah. So why are you starting with GOX and not the next one? Or the next one, or the next one? Okay. Depends on what we start with and what we're given to change. A lot of times what you'll notice is people will immediately start with that piece but not know the reason why. You want to know the reason why?
Yes.
They've solved hundreds of questions that have noted that it usually works, that if we start with the 0.0350 GOX, that the solve works. How many of you have solved hundreds of questions? Okay, you need a better reason than what they used. Okay? Their reason ultimately sucks. Why does their reason suck? Is a GOC the same thing as a SOMOC? No. I'm trying to solve for SOMOCs, and what did I bring in? GOCs. Why the hell did I bring in GOCs? Did anybody do anything with days and hours? Why not? It wasn't up there? Okay, let's fix that. It is up there now. How do you know it doesn't pertain to it? What was our GOX a measurement of? What measurement was it of? What is grams? Weight or mass. And hours?
Is time.
Time. We're shifting the unit measurement system. That's why we can't align those. Okay? But that also makes the assumption that you know that extra information. When you go through to solve something about SOMOCs and GOCs, do you have any clue what the frick a SOMOC is?
No.
Or a GOC? Right? We don't. Right? So what we want is a system that takes us a step back from that. Because if we look at this is a mass measurement, and SOMOCs is not a mass measurement, it's a counting measurement. That's a different measurement system. How can I possibly convert those then? Well, I don't know. I would need some other conversion factor to allow me to do that. That conversion factor is embedded in all of this nastiness up there. Okay? So as a good step one, what could we go through and do? Instead of going through all this, how about we clean up that information? Instead of writing it out all stacked on top of each other where it's impossible to go through and read, let's go through and actually organize it in their own lines. Now when they're in their own lines, it's a little bit easier to interpret. I could see those. Right? We also went through and made some other approximations and simplifications. We called this SOMOCs. Wasn't grams of caffeine we were solving for, it was GOX. So wherever I see seconds of molecules of caffeine, what should I do? What do I want to call molecules of caffeine? Grams of caffeine? Starting to hear the snickers. Thank you, I forgot what it was. How about the next one? Moles of molecules of caffeine. What color am I missing now? I can get green in there. What was molecules of caffeine? Mock. So I'm given lots of information. What information should I start with? Okay, we can even go through and start boxing stuff. There's one piece of information. There's another piece. There's another piece. There's another piece. Which of those should I start with? Okay, the second one. So I'm presuming you're saying 1, 2, 3, 4?
Yes.
One being the first one. So you're saying start with the second here? The third one. You want to start with GOX and MOX. What do you want for an answer? SOMOC. Is MOC SOMOC? Is GOX SOMOC? No. What do you want to start with? Why not the second one? Does that have what I want in my answer? That we'll address here in a second. Okay. Does it have what I want as an answer?
Yes.
Yes. I want SOMOX to show up. Am I given just SOMOX? No, I'm also given I'm given SOMOX related to MOX. The number with our SOMOX, 1. MOX? Is this now going to be a valid equation? SOMOC over MOC equals SOMOC?
No.
No. Why? I need to cancel out MOC, so what do? I want MOX. Am I given just MOX? Where does it say just MOX? It doesn't. Good answer. Okay. It says MOC here related to MOMOC. It says MOC here related to GOC. So depending on what I may try and do, I need to pick that conversion factor appropriately. I'm kind of suspicious that we missed one of these. This was molecules of caffeine. So that was right. That was MOC. This one, yeah, there we go. That's not MOC, is it?
Yeah, no.
That's MOMOC. All right, so I want MOC. Do I want to take MOC to SOMOC or MOC to MOMOC? Why MOC to MOMOC and not MOC to SOMOC? Because I've already used that one. Once I've used the conversion, I shouldn't bring it back in, because if I bring it back in, what happens? It cancels out. So that first one has been used. I don't want to use it again. Okay, which means I'm going to use the next MOC. MOC to MOMOC. Okay, because I'm not given it directly. So now what can I do? I can bring in the numbers. What numbers do I bring in? Where do I place that big number? Not on the top. With MOC. 6.022 times 10 to the 23rd. What goes with MOMOC? 1. What happens to my units? My MOC cancels. Awesome, I got rid of the MOCs. I still got momocs. How do I get rid of those? I need them to cancel out. To cancel out, where must momoc show up in my next step? In the numerator. Am I given just momocs? No. So what else? What am I given about my momocs? I can relate that to gox. Just a second. What's the number? 1 goes with the momoc, and 194 goes with the gok.
So since 1 momoc equals that amount of mocs, and then 1 momoc also equals that amount of goks, can't we just cut out the middleman and just say that 194 goks is equal to 6.022?
I'll address that in a second.
Okay.
Momocs would cancel, right? Okay. Now what? I need to cancel out gox, so I need just gox. Am I given just gox?
Yeah.
Hell yeah. There it is. Drop the number in, 0.0350. What's the number in the denominator? 1. If it's a number other than 1, it's not 0.350 anymore. Okay? What's the unit in the denominator? There was a gutsy answer. Oh, full of gutsy answers over here today. Nothing. If it's anything other than nothing, was I given just 0.0350 gox? No, I was given that related to something else. All I was given was that pure information, which means the unit in the denominator is nothing. There is no unit there. Okay? When we go through and process all of this information, so number 1, we brought in gomocs, mocs, somocs. We created arbitrary symbols to represent how we're going through and solving this. Why did we pick those arbitrary symbols? To make it easier for us to write out, so we didn't have to write out as many letters. Okay? So you're going, well, that's stupid. We would never do that. What's the symbol for hydrogen? H. You already did. Okay, what's my name? You already did. My name is Michael. For crying out loud, we're already making simplifications. Okay, it's just a question of how we put them together. You just don't like that those weird words show up. Who cares? Doesn't matter. Okay, it's completely irrelevant. When we go through and solve these things, you will never hear reference to momoc again unless something weird confluence of events happened again. Okay. We come up with other abbreviations for those terms. Why would we do that? If you walked into the tutoring center and said, hey, what's a momoc? What are they going to say? Okay? But if you went into the tutoring center and asked them, what is a mole of molecules of caffeine? They might be able to answer that question. So the abbreviations that we use need to be abbreviations that are accepted effectively universally. Exactly right. So what we have to do is come up with a notation that allows us to simplify how we go through and solve things. Okay? At this stage, if you ask someone to solve this, they're doing the exact same thing. They've taken moles of molecules of caffeine and they took all of those letters and they made them a single thing. They made them momocs. They just did it in their head. Okay? And they tried to not say it out loud because it's just funny. Okay? But that's already happening when we go through and solve. Everybody that solves these questions is already doing that. What I'm trying to get you to do is to do that also, but to acknowledge that that's what you need to do to go through and solve these. Okay? What happens with the unit systems? All of our units cancel and we'd be left with somocs. Now what can I do? Punch it into a calculator. Just take the numbers and I'd end up with my answer. Okay? Where I'd get seconds of molecules of caffeine. And I'd be done. Okay? I'm taking those unit systems and allowing the unit systems to cancel each other out. This becomes challenging. Because if you think about what you've done in algebra or other math classes, You had x equals y. Okay? You didn't have triple x 34 equals y96g4. Okay? Because that's confusing. Welcome to chemistry. Okay? We're complexing and putting those pieces together, and we have to kind of segment and acknowledge each of those pieces. And the question comes back to is why? I remember at the beginning of this I said, do you really want to start with GOX? And I asked what was your reasoning. Well, you said you were converting. Well, aren't we also converting MOMOCs? Didn't I need to use that? Okay, why did I know it needed to be 1 MOMOC over 194 GOX? It was also given 194 GOX over 1 MOMOC. So I don't accept that it was given. Why do I know that 1 needed to be in the numerator and the 194 needed to be in the denominator? To cancel out the units. To cancel out the units from all of the work that we had beforehand. We could go through and say, well, to cancel out the GOX. Well, why'd you cancel out the GOX? GOX cancel and you get MOMOC. Is that the same thing as SOMOC? No. Okay, so starting with GOX is a questionable thing to start with because you aren't getting to your answer. For those of you going, but yeah, it worked. True. Okay, but why did it work? If it worked because you blindly guessed 50-50, there's a 50% chance you place that correctly, top or bottom. Okay? What happens with the next one? If that was a guess, what's the next one going to be? A guess. So 50%, 50%. The odds of you getting the question right with just those two things, 25%. There's another 50% on top of that. We're now down to 12.5% if you're guessing at where to place these numbers. Okay? The units dictate where those numbers go. Those units can be complex, nasty-looking things. Okay? You're responsible for simplifying those units down to make them look like something that you personally can work with. That then also somehow needs to get translated out to me. Okay? Because I have to grade your SOMOCs and MOCs. Kind of makes sense?
On this, so the reason why you didn't start with the first one was because you're trying to get rid of the other units first?
The reason we did not start with GOX, why would I start with GOX? What do I want for an answer? SOMOC. Is SOMOC the same thing as GOC?
No.
No. Okay. Do I have a direct conversion between GOX and SOMOCs? No. Why are you starting with GOX?
Okay, that makes sense.
You have no context to explain why you should start with that number, other than it was the first number written down. That's a really easy thing for me to fix on a test. What do? I put it somewhere else. Now all of a sudden you screw up all your calculations. Why? Because you don't understand why you're using the numbers you're using when you convert. You're just using them because they showed up. That's a very bad policy. Okay? And we could put that out into the dating world, right? I saw a female, so that must mean we must get married. Whoa, that's a really bad idea. Don't do that. Okay? I saw a male, so that means we must get married. Okay? We have to evaluate things beyond just, it's the first thing I see. Okay? That makes life pretty miserable. Okay? We have to have those protocols. Why would I suggest that we start with SOMOCs to MOCs? In all of the given information, which of those things has the answer I want? That's why I'm going to start with it. And I'm going to place that unit exactly where I want it to be. I want it to be in the numerator. Why do I know I want it to be in the numerator? Because that's where it shows up in the answer. By organizing it that way, I can more smoothly and carefully outline my process of solving. Okay? Are there simplifications that you can make within this? Yes, absolutely, which was Ali's question. And we're going to get to that in a second, but or are you going to ask the same question?
No. I was just, for every questions like this, for the answer, SOMOC, should you always start, Is it always like that? Like you should always start with it too?
Does the order matter? No. Okay, and this is where it becomes challenging. I could go through and I could have shuffled the order for any one of those 4 things into any one of those kind of sections. And I would argue what we have here are 4 sections. Okay? I could place them into any one of those boxes. As long as I place the numerator, denominator the same, it doesn't matter. Okay? So I could have started with any one of those and moved to any one of them. But what is the logic for why I do that? Okay? The logic is only in this sequence. After that, if I start with GOX, why did I start with GOX in the numerator? Because I've solved enough questions to know that that's where it's going to be. So for you as a student, what I'm telling you is that you should start with GOX because you know the answer is that's where it's supposed to be. Do you know the answer on a test? No. Are you going to have me tell you this is the answer, you should do it this way? No. That's a crap method to teach then. Okay? We need to have an underlying logic behind why we're picking and placing those things. And that is exceptionally challenging to deal with. Okay? Fully admittedly, this is not how I learned how to train. Learned how to solve these. I always started with GOX. Why? Because I failed a whole bunch of times, and enough of those times I figured out that it should start in the numerator. And then I just said, yeah, that's just the way it went. And then somebody asked, well, why'd you do that? Because it works. Which means ultimately, I have no clue what's going on with it, but I know it works. Okay? That means I have no idea what I'm talking about. Okay? And only after someone asks that question do I have to go back and be like, well, why did I do that? Okay? That self-reflection is insanely difficult to do. I'm trying to set you up so that you're set to always do this and not have to fail that couple hundred times. Kind of makes sense? Okay. There was a question about condensing this. Okay. 1 MOMOC, 1 MOMOC. Well, those are the same. Couldn't we just cancel and combine those into one thing? Yes. At what cost? As long as you do it right, it should work. Yeah, that's pretty true. Yeah, as long as you do it right, it should work. Yes, and it will. The problem is are you given the conversion of MOX to GOX? No. What did you have to do? Make a connection. You had to make that connection to do that conversion. When did this conversion become apparent to you?
When you started putting...
Oh, when I wrote it down, did it become apparent? Yeah, that's because I wrote it down.
Well, it was when you changed it to MOMOX, like it's from MOX to MOMOX.
So starting to recognize those patterns on how you can set those up is the next stage, because you want to be able to see how to correlate and organize those. Do you have to make that leap? No. This method sets it up so that you would be able to see those connections without having to do simplifications. Do those simplifications save you much time? It's the amount of time it takes me to write MOMOC twice. 2 seconds? 3 seconds? Is it worth it just to write it down? Yes. Okay. The next part behind this, each of these boxes is an individual unit piece of information. I'm not combining multiple things, which means if I now go back to check my work, I should be able to look at this box and find that given information. If I can't find that given information, what does that mean about my box? It's wrong, which then means the whole question is wrong. If I've now started to combine things and I come back to check my work, I can't now find that given information. I have to reinterpret how I got that given information. Okay, on a test where you're already probably going brain numb from answering all these questions. The odds that you can condense those correctly and consistently are slim to none. So I do not recommend condensing those. Write them out. Okay? And it's not wrong, but it's a consistency question. Okay? This is a fun one to enter into the calculator. Okay? So you can go through and try and enter it, and I'll try and come up with a guess. I literally have not solved this one, so I don't know. Times 10 to the second. 11. Can I, 23 minus 9, 12? 23 minus 9 is not 14. I would... Shh. Shh. I was just hoping you would just kind of accept that I didn't say that. 8, 3, order 10 to the minus 15, 10 to the or 10 to the 15, 10 to the 13, something like that. What'd you guys get? You don't know how to use it? Is that what you said? Good intent. Did I really butcher it that badly? Looks like I did. 6.02. I didn't have a calculator, by the way, for those of you being like, oh, you suck. Yeah, you did that right. So I just goofed the math. 2.7 times 10 to the 10. Okay. I can verify that only because I saw that work in the calculator and I know that calculation was correct. If you're getting a different number than that, it is likely because you aren't placing your powers of 10 in the proper locations and they are canceling out inappropriately.
What about
Sig figs. So, yeah, man, couldn't have gotten it right for once. Is this answer correct for sig figs? No. What does it need to be?
It's 2.715.
2.715 gives us enough numbers that we can now work with. 2.715 times 10 to the 10. How many should we report for our answer? How many sig figs? 1, 2, 3. The 2 zeros in front are not significant. Our answer becomes 272 times 10 to the 10th Sagan's. I forgot what the heck the even real thing was. Sagan's of molecules of caffeine. Okay? Anybody know where this question came from? Nope. Exam 3. Straight off exam 3. Practice exam 3. Okay? And you might be like, well, but we don't have to know that. You're right. Okay? If we go through and look, sorry, I just deleted everything. On exam 3, most of this information is given to you. You know what's not? That one and that one. You're responsible still for all of those conversions. Well, where did those other 2 ones come from? Not a bad idea, but those are actually content from exam 3, which is why you're not responsible for it yet, and I had to provide them. That second one, 194 grams of caffeine is 1 mole of caffeine, or is 1 mole of molecules of caffeine. That is actually given to you in this classroom already. 1 mole of molecules of caffeine is 6.022 times 10 to the 23rd. Molecules of caffeine is a fancy number that you will be required to memorize in Unit 3. Okay? That is Avogadro's number. If we name it, guess what? You get to memorize it. Kind of how it works. Okay? So the next exam is taking all of this information of those conversions in that process and now saying use that process and figure out where the hell all these conversion factors are found. You have to know where to find that information and then be able to use it. If you don't have a process on how to use it, it doesn't matter if you know where to find it. Okay? So the point in chapter 2 is to come up with that process so that you trust that process. That process always works. Okay? I've seen a lot of people attempting to cross-multiply, setting up equations. You could do that. That would have been 3 sets of equations that you would have had to use to go through and solve. More writing, more likelihood of mistakes, more calculator entries, more likelihood of mistakes, more likely you get the whole question wrong. Okay? So the intent behind this process is to streamline it and run it into a single line as cleanly as possible. Okay? Kind of, sort of?
Yeah.
Was that glimpse into the future a bit daunting? Sorry. You got spring break to study. It's okay. Double replacement reactions. Okay? Double replacement reactions are a bit, so we can take a step away from all the mathematics now. Okay? The double replacement reactions are a bit more challenging because not only are you expected to be able to recognize that it is a double replacement, you need to be able to predict the products. Okay? Not only do you have to predict the products, you have to decide, did it actually happen? Remember, the chemical equation is a prediction. Okay? It's forecasting into the future. Okay? It says this is what would happen if this did occur. You also have to now be able to say, yes, that is going to happen, or no, that is not. Aqueous barium chloride reacts with potassium chromate. Can you guys do all that, or should we walk through it? Walk through it. Symbol for barium. Symbol for chloride. Cl. Symbol for aqueous. AQ. What's the next step? No. See if what's balanced. I don't have any products. How would I balance this? Balance the formula. Make sure your formula is correct. What is the charge on barium? +2. How do we know it's a +2? It doesn't say it on the periodic table. It's the second column. The second column is a +2. You could write that on your periodic table. If you don't want to memorize them, write it on your periodic table when you get the exam. Okay? What is the charge on chloride? A -1. How do you know that? Okay, again, back to that periodic table and understanding how those charges come about. You could write that on top of your periodic table when you get your exam. Is that formula correct? Why not? It has to be an overall neutral charge, which means I need 2 chlorines. Now that my formula is correct, what can I do? Now I can do the plus for reacts with. What does it react with? Potassium. What is potassium? Ka. Okay. What is chromate? Are you required to memorize? No. You are not required to memorize chromate. Okay. Remember how there's a list of the polyatomic ions in that nomenclature video? I've got purple stars next to things.
Yeah.
Guess where there isn't a purple star? Next to chromate. How would you know this one? It shouldn't have been given. CrO4 -2. What should we do now? Why do I need 2?
No, the other side.
Why? Because you haven't specified all the work. Okay? You've internalized some of that work, which is good. Potassium's a +1. For those charges to balance, I need 2 potassiums. What's the phase on it? Aqueous, aqueous, I don't care. Potato, potato. Produces. Okay, so we would have to look at this and know it's a double replacement. How do we know it's a double replacement? So, simplest answer, which is a good answer, use the information at hand. Right? You tend to not be told to do that. You should use the information at hand. The top of the slide literally says double replacement reactions, which probably means it's a double replacement. Okay, so I appreciate that answer and feedback. How do you know it's a double replacement? Okay. We have 2 compounds and They each have two components within them. Okay? The only format that matches that from our general form for our equations is that for a double replacement. Whoops, I meant to try and remove that. Which means the products that we would get would be barium with the chlorine and
Barium chromate.
I was like, that didn't look right. Barium with the chromate and potassium with the chloride.
You don't have to do anything with the subscripts because both of their charges match perfectly.
Just steal all the freaking thunder from that. What is the charge of the potassium? A +1. What is the charge on the chloride? A -1. Is that formula correct?
Yes.
Yes. Okay. You'll notice on the reactant side, I've circled those 2's. Why is there a 2 next to the potassium on the reactant side?
That was in order to balance.
To balance the chromate. Should that 2 be over here? No, why not? It's not with chromate. It's with chloride, so I can't bring that 2 across. Cl2. There's a 2 there, right?
Yes.
Okay, why is that 2 there?
There's two. It's
To balance the barium. Is the chloride with barium anymore?
No.
No, so I don't bring the 2 across. Okay, formula is plus and minus. That formula is now correct. What else should we check?
Balance.
Sort of. Not yet.
Balance in the
Barium chromate.
yeah.
The barium is
Plus
+2. The chromate is
minus two.
a -2. Is that formula correct?
Yes.
Yes. Is the equation balanced?
No.
No. How do we fix that?
You gotta see how much bariums there are on each side.
We would check the bariums 1 and 1. We check the chlorides 2 and 1. So we need to bring the 2 in front out here.
Yep.
We now have 2 chlorides, 2 potassiums, chromates 1 and 1. Yeah?
Yep.
Sweet. You've now predicted the products, the proper products, and balanced the equation. Fantastic job. Did this reaction happen? Okay, a little bit of review. How do we know a chemical reaction has happened? Activity series is an awesome answer for a single replacement reaction,
Solid, gas, or liquid is.
which this is not. So the activity series is not useful. We want a broader reference for how a chemical reaction happens. And what are you now saying?
You know a reaction has occurred if a solid, liquid, or gas has happened.
Okay.
Or-
If we see a change in phase, we know a chemical reaction has happened. What else? And I'll give you 2 for change in phase. So there's 2 more left. Don't worry, it's not like it's on the test on Thursday. It is. What's that? Nope. Solubility is a change in phase.
Change in energy.
I don't care about that. It's irrelevant to the question that's up there. How do I know a chemical reaction has happened?
A change in energy.
A change in energy. Yes. Last one. There it was. Change in color. Okay. One of those 4 things needs to happen. When we look at a chemical reaction written out, do we see anything about temperature? No. So we're not going to expect to see temperature show up in this. Do we see anything about color? And don't tell me it's written in color. That's not relevant. Okay? No. Okay, which means it's going to have to reference the change in phase. Have I specified the phase on any of these?
No.
Are you responsible for that? Yes. That's how we know a chemical reaction has happened. So how do you know what the phase is on each of those species? The solubility rules. Your double replacements will require you to use solubility rules. Okay? We'll look at those solubility rules in just a second. There are 3 that I recommend that you memorize. Okay? Anything with a group 1 element is soluble. Anything with nitrate is soluble. Anything with acetate is soluble. And don't stress about writing it down. We will see it pop up on the next slide. Okay? Potassium. Group 1 element, which means anything with potassium is soluble. What does soluble mean?
It dissolves in water.
It dissolves in water, which would thereby mean it is Not a liquid. Aqueous. A liquid would be a pure substance. This is dissolved in water. It's not pure anymore because we have another species. So the potassium chloride is aqueous. When it comes to me personally on a test, I haven't memorized whether this one should be solid, liquid, or gas. All I know is it doesn't match any of the solubility rules I've memorized, which means what am I going to do? I'm going to guess that's a solid and move on. Okay? Or I could hope that my instructor is a somewhat decent person and doesn't think that I need to memorize all of the solubility rules. So we might put it on the front of the exam. If you look to the front of the exam, does it list the solubility rules?
Yes.
Not completely evil. Okay, they are there. It turns out that that is a solid. I don't know if that's actually one I listed there because it is?
Yeah.
Oh, wow, look at that. Okay. There's tons of solubility rules. And we see this table and go, oh, God, 10 rules. That's horrible. There ain't 10. Try like 100. Okay. There's tons of solubility rules. Okay. So what you will be given on the test is not all of them because that's just dumb. Okay. What I will give you is ones that I think are going to be important and probably a few other ones just to mess with your brain. That's just how it works. Okay. So how do we use these rules? Okay, we'll pick a species, potassium chloride. I need to find potassium or chloride. Okay, you found potassium. I disagree. I found chloride first because I count down. Rule number 4, halide ions. Halide ions, it says X, chloride. Okay, mercury and lead are exceptions and are insoluble. What the hell does that mean? There's a reason there's a header on this. Everybody laughs. That's funny. I would never make this. Calm down. Yeah, you would. You all screw it up. It's fine. Okay. It says are generally soluble. Okay. Halides are under the soluble rule. If they're soluble, they dissolved in water, which means aqueous. If there's an exception, that would mean not aqueous, which solid. Okay? So according to the halide rule, it should be soluble. Okay, someone said potassium. That's awesome because you count from 1, 2, 3, 4 like a normal human being. Alkali metals and the ammonium ion. Potassium is an alkali metal, soluble. So potassium chloride? Soluble, aqueous, fantastic. Barium chromate. Okay. Cool, I totally love where you guys jumped on, but I see barium first. That says barium is soluble.
No, it's an exception.
Is that relevant? Why is that not relevant? That is for barium sulfate. It's not just find the letters that match, also look at the context. Okay? That barium isn't relevant to me because that's barium sulfate. I'm looking for barium chromate. Okay? So I can now slide through, find my chromate. I have exceptions, but in general, the rule is that they are insoluble, which means these are all solids. Of course, there are exceptions, and the exceptions would mean aqueous. Is barium one of those exceptions? No. Chromate ion are insoluble, so solids, except for rule 1. Barium is not a group 1 element, so I don't care about the exceptions. So the barium chromate is a solid. This is how you use and interpret this. Okay? You have to read the context of that information. Kind of make sense? Questions? I heard a no, so we'll accept that. Why did I memorize only 3?
The most common.
Common isn't usually a bad answer. It's not necessarily a wrong answer here, but I would say there's a better one. What is the difference between what is in the red box and what is in the green box? Everything in the green box has exceptions. Everything in the red box, no exceptions. I'll memorize the stuff where I don't have to memorize more things. Thank you very much.
So then why does it say generally?
The generally is referring to everything in that category. In both cases, it overlaps differently. Okay? Make sense?
Yes.
Yep.
Cool. Neutralization reactions. Does that general format of a reaction look familiar to you?
Somewhat.
Somewhat good. Test Thursday and all. Oh, that's good. What does it look like? It looks like a double replacement because it is. Ta-da! It's a double replacement. Why do we reference a neutralization reaction and not as a double replacement? Okay. All sorts of interesting answers came out of that, which was pretty amazing. Like, this just happened at one of our meetings, and someone was like, why on earth would we talk about neutralization reactions? This was a faculty member. When they're just double replacements, this is stupid, we should never do that. You all just had answers for them in like seconds. That was pretty cool. Okay. What were those answers? Acids and bases. Why would I care about that? How many of you heard about an acid before this class? Okay. How many of you are just ignoring me and not raising your hand? Yeah, that's what I thought. Okay. Almost everybody's heard about acids and bases before the class. Why? They're dangerous. Why do we know they're dangerous? We discovered them a long, long time ago, and we created a class of naming of them. That's why we call them acids. We have their own naming system. They are ancient, ancient, ancient reactions. And because of that, they were discovered first. So arguably, double replacement is a bad name. Double replacement should be called neutralizations, but then it doesn't match the pattern. So we had to create a new category that was broader to incorporate all those other reactions for our double replacements. Okay? So why not just get rid of the neutralization topic altogether? How many of you heard of acid and base reactions before the class? Okay? It's ancient chemistry. Okay? To that same token, I would usually ask, what is the name for the compound H2O? Really? You want to call it water, not dihydrogen monoxide? Okay. Why do we call it water and not dihydrogen monoxide? Because it was one of our initial discoveries and naming, and we've been stuck with that name ever since. Same deal's happening with a neutralization. It's a historical context. That's why it's here. Okay. Not only is it historical, acid-base reactions are inherently important, and they need to be separated out so that we can draw attention to them, particularly for people that want to do anything in biology, because nearly all of the reactions in biology are neutralization reactions. Virtually none of them are run as double replacements. Okay? So there's a stronger argument that double replacements shouldn't be discussed, because why? Okay? So back to the neutralization. We're taking an acid. How do we know it's an acid? Okay, it has an H. Okay, so a way to refine and not catch the mistake that the other class did. We have an H in front, and officially, we also need the AQ in back. Okay? In my general formats, I didn't include phases because I don't like phases. Sorry, that's just why. Okay? So that's how we know we have an acid. How do we know we're reacting it with a base? Because we see the presence of hydroxide, OH minus, okay, which should also have the AQ. When we run this acid-base reaction, I will neutralize the acid in the base. What's the part that makes it acidic? The H or the A?
The H.
The H. How do we know it's the H?
That's really reactive.
Two fun answers.
Acids start with hydrogen.
All acid starts with H. Okay, that's why it's important. The other reason why we could reference it as important, okay, let's pick a nice acid, HCl, right? Everybody feel that is an acid?
Yeah.
Okay, which is the dangerous part, the H or the Cl?
The H.
We said the H, and if you're ever curious as to why, Look at that. And you say, well, the Cl is the dangerous one. You're like, well, sodium chloride? That's not dangerous. Exactly, because it doesn't have the H. The H is the dangerous one. Right? When we cry, if chloride was dangerous, there goes our face. Okay, and not just like red from heat because people are staring at us while we cry. Okay? Whatever. Let's leave that one alone. We'd be crying because our face is literally melting off. Okay? So it's the H that's the dangerous part. So when we go through and run the reaction, what happens to the H? What do I partner it with? The hydroxide, thereby making HOH, also known as H2O, also known as water. So when we run a neutralization reaction, we will always produce water. Right? What happens to the remaining pieces? Well, one is negative and one is positive. So what happens? They come together to form a bond. What kind of bond did they just make? They made an ionic bond, which makes this a salt. What kind of bond did the H and the OH make? A covalent bond. Okay? That covalent bond causes enough of a difference in energy that we're now seeing the chemical reaction. Okay? So that is our neutralization reaction. As far as phases go, HOH, what phase?
Liquid.
This one comes in as liquid, not as aqueous. Okay? The salts comes in as our aqueous. For those of you saying, well, why is HOH not aqueous? What does aqueous mean? What does AQ mean? Sorry, I heard acid. No, AQ with hydrogen in front means acid. What does AQ mean? Dissolved in water. Would you really want to say water's dissolved in water? Okay, so no, it's not a logical statement to go through and make. So if we went, yeah?
I was just going to say, with the neutralization reaction, we're always going to get water as a product. Is that what you said?
I said it in the hopes that no one would actually step up and try and challenge that. For the sake of this class, yes. Reality, no. Horribly, falsely, horribly, no. Okay, but by that same context, acids aren't just H in front and aqueous in the back. Okay, it's a simplification that we use for the sake of the class. Okay, so if we go through and look at our reaction, complete the neutralization of sulfuric acid with potassium hydroxide. What kind of reaction is it? Should have been a little faster. Neutralization. Work on that. Okay. Sulfuric acid. H, good start. Okay, I'm now hearing a couple things. I heard H2S, I heard HSO4, and I heard H2SO4. What is the difference between the first one and the bottom two?
Ternary and binary.
Ternary versus binary. How do we know the difference in the name?
Ternary is
So one option is going with a negative. We could say the ternary means no hydro in the name, or the binary requires the use of hydro. Do we see hydro? No, which means? It is not H2S. Okay, because that is a binary acid. That would be hydrosulfuric acid. Between HSO4 and H2SO4. What is the charge on sulfate? A -2. A charge on hydrogen? +1. Which formula is properly balanced? H2SO4. Make it better. AQ. Reacts with KOH. That should have said aqueous, I apologize. To produce. Okay. HOH and KSO4. What is the charge on hydrogen? A +1. Charge on hydroxide? -1. Is that formula correct? Yes. What phase is it? Liquid. Charge on potassium? Charge on sulfate?
-2.
Is it balanced? What do we need? 2 where? 2 is a subscript after the potassium, and we now have our potassium sulfate. What phase? How do you know it's aqueous? How do you know it dissolves in water? Our solubility rules, someone started shouting out potassium. Yes, potassium is a group 1 metal. That should be aqueous. Typically, when we look at our neutralization reactions, the salt will come in as aqueous. On the rare occurrence, it is possible that you could be forced to use your solubility rules. Okay? Because it is technically a double replacement. You could have to be using that. Would this formula or this equation be balanced?
No.
What do we need to do to balance it?
Put 2 on the other K in front of it. KOH.
Okay, and we get 2 potassium hydroxide. This way, the potassium's balanced. Does the hydroxide balance? How many hydroxides do we have on the left? 2, because the 2 in front. How many hydroxides on the right? 1. Does it balance? What do you need? 2 here. Now it balances. For those of you that want to write out H2O, that is fine. You could write out H2O. The reason I don't write out H2O is HOH allows me to balance hydroxide independent of hydrogen. Okay? It's a little bit simpler for me personally to balance. Some people find it easier. Some people find it more difficult. It's entirely up to you. It's a choice. Yes?
Now, do you still want us to do the ones and the other ones and then add them up?
So, do you need to include the ones? No. Okay, that is entirely wrong. By writing that down, a 1 has been implied. The only reason you would include a 1 is for your personal benefit. If I ask you for the sum of the coefficients, one of your answers is going to be 4. What did you do? 2 and 2, or 1, 1, 1, 1. Okay. What did you not include? You forgot the ones here because they were implied. If sum of the coefficients, yes. Okay, it's pretty much the only way I can ask a balancing question. Okay, so the answer in this case for some of the coefficients would be 6. 1 plus 2 is 3 plus 2, 5 plus 1, 6. Good? Cool. Okay. Our combustions, okay, are the reaction of an organic material with oxygen gas to produce carbon dioxide and water. You are expected to predict these and balance these. Okay? That's because they always come out to be the same thing. So I'm going to take some carbon and hydrogen containing compound, react it with oxygen requirement, and as a requirement, it will produce CO2 and water. When? Always. It's always that. It's how it works. The only thing that will change is the number of carbons and hydrogens, okay, which means balancing the equation could be difficult. This is one of those difficult ones to balance. I don't want to spend time on it because you're looking at a very minimal amount of questions potentially showing up on that.
Will there ever be a third product, or is it always just going to be?
For the sake of this class, when we look at a combustion, no, this is it. Okay? Combustion ultimately just means reaction with oxygen. It doesn't have to be organic. Okay? This kind of gives us some context. Okay? Officially, this material is not on the next exam. Okay? But we can kind of use this to help get an idea and maybe relax a little bit. How would we determine the volume of those shapes? Okay, so the first one, we could do triangles and an oval, do all the algebra, gymnastics. I think I meant calculus. Those are about the same, right? Okay, to go through and predict out the area of that weird shape. But what about the crown? Would that be easy to determine a volume of? Okay, not through that. We'll deal with that in a second. This image, what am I asking for the volume of?
The statue.
Not asking for the volume of the statue. It's really hard to get a picture of this. I'll be like, what the hell kind of picture is that of? Come on. The volume of the gas? How do you get the volume of a gas? Okay. So those aren't easy things to get volumes of. Okay. So the way that we can go through and determine those is through displacement with water, which is what you were suggesting. Okay. So we can just drop it in a container of water before and after, and we get a difference. That difference is due to the volume of the object. Okay. So pretty straightforward. Okay. We can also do it for gases by displacement through this fancy apparatus. This is one we have to be a little bit more careful of. Okay? Has anybody taken, I don't know, like a balloon and added some hot air to it? What happens? Okay, we could say it explodes. There's people that actually do this for a pastime and living and hobby. And I'm pretty sure it's not that it explodes. It inflates until eventually it rises. Hot air balloons? Okay? What happens when we add heat to gas? It moves more and it expands, which means this could potentially mess with my measurement of the gas. Because what I could be seeing a change in volume due to is due to the temperature, not the gas. Okay? Which means I have to separate the heat very far away from where I'm measuring the volume. Okay? I have to make sure that the temperature where the volume is being measured and monitored, okay, stays constant. Because if it changes, I'm not measuring the volume of the gas. So I have to be a little bit more careful with this. How would I do that? It's pretty simple. I just make sure there's a bunch of area in between that isn't being heated. So I give the gas enough time to cool back down to room temperature or whatever temperature I'm monitoring this volume at. Okay? And just because I think it's fun, we can throw it in there. Which weighs more, a pound of lead or a pound of feathers? Okay? Remember those saying, ha ha, maybe